Okay, my friends, Roger once again doing a research only, not making any medical advice whatsoever. However, there is some new information about this adenomyosis versus endometriosis. Both of them affect women because it's in the female body parts, and it affects as many as 1 in 5 women. Now that's just this adenomyosis. The other one, I'm not sure how many it affects, but this is pretty common among women, and it has to do with the reproductive system. Okay, it appears from the research that it has to do with fascia. Now here's the deal. Adenomyosis is this. It's when the tissue that normally lines the uterus grows in to the muscular wall. It's not supposed to grow in there. And this is the uterus, and when a woman has her menstrual cycle, this becomes very painful and so forth. And the doctors aren't sure what causes it, but the disease usually resolves after menopause. After menopause, you don't have this kind of interaction where you're getting ready to have a baby. For women who have severe discomfort from this, hormonal treatments can help. Removal of the uterus cures it because it's no longer there. Now, what is the other one? What is this endometriosis? See, this is adenomyosis. Now, don't forget, this is where the muscle grows in. Well, the other one, the muscle grows out. All right, see, this is endometriosis, a disease similar with which tissue similar to the lining of the uterus grows outside the uterus. It's not supposed to do that. There's supposed to be membranes that keep this stuff that way and this stuff this way. Why is that membrane allowing these things to either grow that way or grow this way? Let's think about it. Okay, this is a woman's reproductive organs, and there's a lot of stuff going on here. Now, every single bit of this has to be separated from other stuff with fascia. If it's not separated, they grow together. Cancer is basically the same thing, where the tissue that lines an organ and so forth is invaded, and the cancer grows in and grows tumors. Well, this either it grows out or it grows in. All right, and this is a very different situation than organs. Well, it's not really different, but it's more of a tissue situation rather than an organ situation. It's hard to explain, but this won't kill you, I don't think, where the organ failure will kill you. And here it's just discomforting and terrible and nasty and all the other things. But it is strictly, as far as I can determine, and again, research only, no medical advice, this fascia layers are weak and they allow stuff in, or they're weak and they allow stuff out. It goes both ways because it's a double layer. There's a layer on the top and a layer on the bottom. And this stuff keeps stuff out this way, this keeps stuff out this way. It can invade in this way or it can invade out that way, either way. Okay, this is my paper from 2015 up on academia.edu 8 years ago. And this is when I pointed out fascia. They had no clue about this. It's been totally misunderstood forever. Fascia protects every bit of you from invasion. Fascia protects you from invasion, including a complete fabric bag that is your skin. That's literally fascia, and it protects you, keeps all the nasty stuff out, and keeps the good stuff in, if it's working. Your skin is not just one fabric either. There's all kinds of skin. You have tough skin to fine, thin skin. Depends on where it is on your body. If it's on your fingers and so forth, it's grip skin, tougher than hell. Very dense with silicone. All fascia is made of collagens and keragens, the fabrics creating fiber, and elastins in a sheet wraps every single thing individually and then comes together as one giant system. This is from my work almost 10, well, it's over 10 years ago, but this is the paper I finally wrote. And there's over 20 types of collagen. There's about 28 or so they claim, but who knows? There could be more than that. And they all come in different strengths, and they're all infused with silicone. All right, there's no reason to get too deep into this, but fascia separates every single thing in your body from the next thing down. It's a layer. It's a membrane. You stay that way and you stay this way. And I will keep you apart. If it's growing in this way, well, you got an issue. If it's growing out that way, you got an issue. The fascia is not working. What makes the fascia work? That's the key. What it actually makes fascia so protective? All right, you see this? This is the newfound organ. They just decided, well, we're going to give it a new name, called it Interstitium, a newfound organ. This is 2018. My paper was 2015. They would still not know about this if it wasn't for my research. All right, and this is what it is right here. They never could find this before because every time they autopsied people, this was flat and all the fluids ran out of it, so they thought it was a thick wall. It is not. It is a fluid-filled highway. And that fluid-filled highway, just as I said in my paper in 2015, that contains all the enzymes and bacteria that keep this thing protective. If your bacteria is not there, you're done. The bacteria is what creates the enzymes. The enzymes are what creates the chemistry to keep out the bad stuff and keep in the good stuff. It's strictly related to fascia, which separates these layers. There's no other possibility for it just to be able to penetrate this way, penetrate that way. It's this wall is of fluid-filled highways, doesn't have the right fluids, which are made by the bacteria, which are the enzymes. If you don't have that, you're going to be sick. It's going to break through. And that's what cancer is. That's what every single invasive disease, 100%, invades. There's no other way to look at it. All right, I'm just going to finish it up right here. This is from that same article that they discovered interstitium in 2018. Well, I disagree. I discovered interstitium. With all that's known about human anatomy, you wouldn't expect doctors to discover a new body part in this day and age. But now researchers say they've done just that. They discovered it. Well, I say I discovered it. They found a network fluid-filled spaces in tissue that hadn't been seen before. They never saw it because they weren't working with mudfossils. They were working with, well, here's what it says. The fluid-filled spaces were discovered in connective tissue all over the body, including below the skin, the lining of the digestive tract, the lungs, the urinary system, surrounding all the muscles, tendons, everywhere, according to the new study detailing the findings. And this was just published, the new study they did. Well, it was my study. Previously, researchers had thought these tissue layers were a dense wall of collagen, a strong structural protein found in connective tissue. But the new findings reveal that rather than a wall, this tissue is more like an open, fluid-filled highway. Exactly what I said in my paper. And then they sort of take credit for it. But this is what does the separation of the layers of tissue. It's not just a flat sheet between them. It's filled with this fluid-filled enzymes. That's what protects you. And the only way you get the enzymes is to have the bacteria. Okay, I worked with people all over the world associated to fascia, which was completely neglected. They didn't even know it existed, basically. They knew there was fascia, but they didn't realize the extent of how these fascia membranes work and what the space inside them is a fluid-filled highway that contains these enzymes and bacteria that create the chemistry to make your body work. They didn't even realize it was there. So I studied this long ago with people in Europe and so forth. In the United States, very little interest. I had found one guy, and I worked with him. He was fabulous. I don't want to mention his name because people attack people that work with me. That's just a fact. So, but he was extremely helpful. He's the only guy I could find that knew anything about fascia. This goes back to 2010. At that time, they called it fuzz. They didn't even realize it was just fascia. It was just so fluffy stuff that was packing material. Had no function whatsoever, basically. Now it's the most important organ in the whole body. Okay, I worked with people in Germany, and it was about Rolfing. Rolfing is a way to smooth out the fascia so you don't have injuries and pain. And that's what they were looking at. It was all about pain and injuries. And they had the first Congress, research congress in 2007, and that was just so that people could start talking about fascia. Nobody knew a damn thing about it. The second one was in 2009, and that one there they were talking about rehabilitation research of the fascia. How do you fix it when it breaks? And because these are sports injury people, basically that's what it was all about at that time. Fascia was a sports injury related thing. Now, the third one now went up to 2012. By this time, I'm involved. And they had a sold-out conference, offered a presentation on the theme fascia. What do we notice? What do we know? Continuing the scientist clinical dialogue. Now they're getting into clinically diagnosing it rather than just a pain and how to flatten it out and how to smooth it out so you don't get all these knots in it and so forth. Then we go up to 2015. This is when we start getting serious. All right, see here, 2015, this is when I wrote my paper about the fascia and how it facilitates fossilization. So I had to know everything there was about fascia, so I'm contacting this guy, Robert Schleif, very nice guy, and I talked to him, and he was from Germany, and he mentioned that they were finding tattoo residue way down inside fascia, inside the body, and organs and everywhere else in the fascia, and that it was... I had mentioned that it appears to be a bilayer system that is like a fluid-filled highway, and that's what I wrote in my paper. And he said, well, it's funny you say that because we found tattoo going all through the body. So it's moving through the body through this layer. And this is when they started to get serious about clinical analysis of fascia because of my discovery that it was basically not what they said. They said it was just a flat sheet. It's not. It's a fluid-filled highway. Exactly what I showed in my paper. I'm sure I mentioned it. Okay, I'm going to show you something from UC Berkeley, fairly recent. But this is the layer. Once again, it's a newfound organ. 2018, they agree. This is where all that fluid flows through your body. And inside there is bacteria and enzymes. And that's what keeps the stuff out this way and keeps the stuff in this way. Now, we're breaking through there, both different directions in this female issue. All right, you know that you have skin, and under your skin, your flesh can move all kind of different ways, and then it comes back. This is what causes it to come back, these locking balls that are in your interstitium. Well, above that is this layer, this one thin layer, which is a double-walled layer that says, I have enzymes in here. I have bacteria living in here. And if anybody tries to come through this way, I'm going to send my bacteria out and my enzymes and kill you. If you try to break through this way for some reason, I will also suppress that and keep you from coming out this way. And that's what's happening in this endometriosis and the other one. It's breaking through one way or the other way. And it doesn't matter which way it breaks through. You're not supposed to break through this layer. This is literally your immune system. Every single invasive disease breaks through these layers. There's no other way to look at it. All right, this goes back 4 years ago. I posted up here, and 3 years ago, I made a comment that I understand this stuff, and we can possibly help people. Now, here's what this guy Gokal, he said with UC Berkeley, I believe, and this is what he discovered when they had a new way of looking at the body where you didn't have to kill the tissue and do a post-mortem autopsy where they're dead already. You could look at it as it was happening. And here's what they found, and he freaked out. So this is Gokal, and it says, your textbooks are wrong. This is what cells actually look like. And what is he looking at? He's looking at the interstitium. And I'll show you exactly what he's looking at. What he's going to be looking at is this right here. All in here. Now, here's what he's primarily going to be looking at, this layer right here. And what happens is he's going to be down in these white cells. All right, they shoot the stuff out into the fluid-filled highway and delivers it wherever it has to go, and it does it instantaneously almost. If you take drugs and so forth and put them in under your tongue, and they seep right in within a couple of minutes or so, it's already in your body. It's very, very fast, and it has to be fast to suppress these invaders, and that's what it does. And here's Gokal going to explain it. All right, here he goes.
Something that I will never forget. The hair on my hands just stood up. It's a microscopic universe within each cell.
This is an unprecedented view of the cellular world, where we can actually see immune cells scooping up sugars in the ear of a zebrafish in real time.
Focusing only on the crawling immune cells, we've noticed two classes of them. One was not hungry at all, but it was very active in terms of trying to figure out, what the environment is. There was another one that was kind of sloshing around with a lot of food in its belly. We can actually conceptualize and visualize and analyze the contents of each of these cellular compartments in this crawling immune cell as it's kind of, scooping up its environment. I mean, that is a level of details no one's seen before.
All right, I'm just going to cut it off here. You can come up and watch it. But these are these white blood cells, and inside of them live these bacteria, and they create the enzymes. They grab up a bunch of stuff, they shoot out into the fluid-filled highway, and they deliver it. And the bacteria also go out and they consume wastes and break them down, and then bring them over and deliver them to the lymph system and the lymph nodes. It's extremely, extremely important that you have the correct enzymes, which means you have to have the correct bacteria. And, they're finding a lot of probiotics, and fecal matter transplant seems to be very, very effective at treating problems with the bacteria in your body. And they're just starting to get into that research, but I've been looking at that research for a very long time, and it is very, very, very promising. And all it is taking somebody else's immune system, basically, because the immune system is nothing more than a bacteria. That's what makes all the enzymes. 100% of the enzymes that make a chemistry are made by bacteria. So if you've taken probiotics, or you have some kind of damaging thing to your fascia probiotics, your good bacteria, you got to replace it, and it's very hard to replace. These layers don't let things in very easily. It's a sealed highway. So once you destroy the stuff that's inside here, you got to somehow get it back in here. It appears that a fecal matter transplant does breach these barriers because you're getting somebody else's extremely good bacteria. You have to have a good source, a good donor, and now they're using like 4 or 5 donors all into one, a dried pill. You take it, and it seems to work pretty good. You can look into this. Again, I'm making no recommendations whatsoever, but if you look up fecal matter transplants, you're going to find out this is what it does. It replaces enzymes. Anyway, that's my presentation for today. And again, no medical advice whatsoever. But it's time that doctors looked into this. As you see, 2018 is the first time they even knew that this existed. They didn't realize it was there. So they had no reason to believe that it was involved in your immune system. And now it is basically your immune system. It's the fascia membranes to keep bad stuff out, keep good stuff in. That's what invasive disease is. And a lot of diseases that are long-lasting things like long COVID and so forth, if you don't have the right bacteria, I don't care how long your body tries to recover, it's not going to recover well unless you have enough of the good bacteria to do the job. Some people, they get COVID, 10 minutes later, they're back up and running. Other people, they never get over it. Why? That's the key. That's what I look for, is the why. All right, I love you all. Bye. What you might not understand is that interstitium coats every single fiber of your body. All your nerve fibers are wrapped in interstitium. And if you break through, you have all kinds of nervous conditions and who knows what. But this is what cancer is. But every other disease is exactly the same. If it invades, it has to break through that layer of interstitium. This is like your skin, and it starts to invades, and unless somebody comes out to stop it, it just keeps going. Once it gets into the really heavy-duty good tissue down there, it just grows like crazy, and then it kills the organ. Now, there's over 200 different cancers. Why? Why? Because, you got your kidneys, you got your heart, you got your liver, you got your pancreas, you got all these different, your skin, your bones, they're all different cancers. The reason is they all have their own specific interstitium, which means there's a specific molecular chemistry because it's dealing with acids or salts or some other toxic stuff it's wrapping it up to keep it away from everybody else. So its specific chemistry is much different than the guy next to it. All right? This one has acids. This one has salts. This one has bloods. This one has gases and oxygens. This one has poop. This one has urine. It's all, everybody's got a different coating. So if one coating goes bad, you may get bladder cancer. If another coating goes bad, you may get lung cancer. If another coating goes bad, you may get skin cancer. It doesn't matter. The chemistry is so specific here. And it's just an exotic, unbelievable. Well, let me show you what an enzyme looks like and how it does get produced. And it does get produced in this layer from bacteria creating enzymes. All right, let me try to lay this out for you. There's three things going on. There's these guys right here are the bacteria. These are single cell, one single cell. And all their job in life is to produce these ribosomes. You see these little blue balls? They have flagellas, most of them, and they can zip around this fluid-filled highway like a rocket ship. And there's literally tens of thousands of different species. Every one of them creates a different ribosome. And that ribosome is an enzyme. You want to see what happens, what an enzyme looks like and what it does? I will show you right now. All right, just to make it a little clearer, I hope. This is the bacteria I just showed you. And inside the bacteria, it has its own special DNA that says, I am going to make this exact enzyme every single time and shoot out these little balls, these ribosomes. And they shoot them out. And that's what they shoot out, is these ribosomes. And this just tells you about the chemistry inside it. You don't have to know that. All right, so you got your bacteria, and it has its own DNA, and it's popping out these enzymes, which they're encased in a ball. And here they come out like this, and the sheath opens up, and you get either an enzyme or a protein. This one breaks, and this one builds. That's so simple as that. And the bacteria do both of them. Some of them make stuff that break your food down so that you can digest it. Some of them make stuff that are building blocks, protein building blocks that build up muscles and tissues and tendons and eyeballs and everything. These break down foods and they kill invaders. Enzymes are deadly, and they are complicated. You see this? After it unwraps, that's what an enzyme looks like. And if it's not exactly identical to that, no difference whatsoever, it doesn't work. And what are all these little dots here on the end, these little tips? That is the magnetic moment signature of that specific bacteria, enzyme basically. And the only way you can get that is if you have this lactobacillus bacteria. If you don't have the and you have the you don't get it. Or if you have the you don't get it. You have to have the exact bacteria to squirt this out. And if you do not have that, you cannot make the chemistry that fulfills the functions within your body. You can't break things down. You can't attack your invaders. It's not that hard to understand. You see that? That's bone cancer. What is bone protected by? It's protected by a membrane. Somewhere along the line, it poked a hole through that membrane and then started to invade. And the membrane can't protect itself because it does not have the bacteria to create the enzyme to fight it off. It just can't fight it off. So it continued to invade and grow crystals off of the substrate, which is down below the membrane, into your good viable tissue. So what this has done is invaded, and as cancer invades, just exactly like this. Only that was all crystals and spikes and all that. And it was invading everywhere, so the guy probably had no good bacteria whatsoever. You can be on the borderline of good bacteria and not enough of it. And you can have bad bacteria and too much of it. It's a game between the two. Everything is trying to invade you. Everything wants to live, and it lives by invading things. Well, we live by stopping things from invading us. Basically, it's as simple as that. And this particular layer right here is that interstitium layer, which is the fluid-filled highway. You don't have the bacteria in there and the enzymes, you're invadable. That's what's called a pre-existing condition. If somebody gets into you that your body can't stop because it doesn't have the chemistry here, you become invaded. All right, let me just explain it. It's extremely simple. Enzymes are chemistry. They're chemicals. They are not alive. They are chemicals. It's those little balls. They open up into those exotic looking enzymes, chemicals. They are complex and very, very complex, and they're produced by bacteria. As I said, you don't have the bacteria, you don't get the enzymes. The enzymes are the chemical. You're not going to get the reaction. They cannot reproduce. Enzymes can't reproduce by themselves, or they can't actually consume waste. The bacteria consume the waste, and the enzymes break the waste down into little bits and pieces, and then bacteria can consume them, take them over to the lymph nodes, and they can be expelled from the body. They speed up chemical reactions without getting used themselves. It's called click chemistry, and here's what happens. Remember I showed you that bacteria here, that enzyme here, it is like this, boom. It's got to be exactly identical to that every single time. And there's one that goes sniffing around and says, hey, go over there, there's a guy down on the arm, and you go get him. Bzzz, pow! All it does is click, and they're dead instantly. When I say instantly, these things can create millions of reactions, just like that, where it would take years to have those reactions happen. These are catalysts. They just run, and it's done. And then they just go on to the next one. They don't even get used up. It's click, 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 click. And it's unbelievable. I've watched them actually in operation. These macrophages going around, chasing around bacteria. They grab a hold of them, and they just destroy it. This should be looked at in much more detail about the interstitium. That's my words on that. All right, this goes back to 2012. They're just trying to understand how the immune system detects bad bacteria and how it works. They have scout bacteria for the macrophages, and that's what I'm going to show you in a second in this new technology they have discovered where they can actually watch this happening. Okay, this is from Seeker. This goes back about 4 years ago. I commented back then, as I said, hey, I understand this stuff. Can we talk? And I never get anywhere with anybody. So here's what he is talking about. This is Seeker, and this is Go Call. I believe it's UC Berkeley. And they discovered this new way of looking at the actual biology as it moves. And I think I understand this. He's going to show a little thing scooping around, and it's grabbing up a whole bunch of stuff, and it goes out into the fluid-filled highway. And I believe that's a bacteria collecting some kind of stuff to go out and attack something. They think it's scooping up sugars. I don't know why they think that, but that's what they think. Here goes.
I still remember the moment. It's something that I will never forget. The hair on my hands just stood up. It's a microscopic universe within each cell.
This is an unprecedented view of the cellular world, where we can actually see immune cells scooping up sugars in the ear of a zebrafish in real time.
Focusing only on...
I just want to say something. It's an immune cell. What's it scooping up sugars for? Sugars are something that you want to go and deliver for food. This is an immune cell. I believe it's scooping up enzymes to go deliver them.
The crawling immune cells, we've noticed two classes of them. One was not hungry at all, but it was very active in terms of trying to figure out, what the environment is. There's another one that was kind of slouching around with a lot of food in its belly. We can actually conceptualize and visualize and analyze the contents of each of these cellular compartments in this crawling immune cell as it's kind of, scooping up its environment. That is a level of details no one's seen before.
We're living in a new era of cell biology, where microscopic...
Yes, we are. We can see things happening now, and they're still being dismissed and not really taken serious. This is 4 years ago. The interstitium is something that they have to really, really, really focus on. That basically is your immune system. It's a newfound organ. All right, I'm not making any statements about you should do this or shouldn't do this. This is not medical advice. This is medical research.